Hello guys, welcome to the KC YouTube channel. Today we are going to be solving an exercise from the reanalysis course, which is from the civil engineering students in the Faculty of Engineering and Technology in the University of Boya. So the name of the course code CIV210. That's level 200 reanalysis. Okay, so let's look at the question. So the question again is CIV210 tutorial exercise 4 RC circuit. Now consider a resistor R and capacitor C connected in series. A battery providing an EMF E connects to this circuit by a switch. Initially there is no charge on the capacitor. When the switch is thrown to B, the battery disconnects and the capacitor discharges with energy dissipated in the resistor. Here we determine the voltage drop across the capacitor during charging and discharging. So we have this diagram for the RC circuit. Okay, now the continuation of the question says the equation for the voltage drop across a capacitor and a resistor are given by VC equals Q on C and VR equals IR, where I is equal to dq, so change in charge with respect to time. Apply Kirchoff's voltage law when the switch is thrown to A, that's the A part of the equation. B says hence establish the differential equation of the circuit. C says solve this equation and then give the expression for the voltage VC. This is when the switch is thrown to B. Apply Kirchoff's voltage law and hence deduce its corresponding differential equation. Okay, so let's look at how we can solve this question. So the first thing we want to look at is the A part, which says apply Kirchoff's voltage law when the switch is thrown to A. So if the switch is thrown to A, it means this is our loop. So this is basically our loop, this outer loop. And since this is our loop, it means this battery charges this capacitor. So this is a charging process. And applying Kirchoff's voltage law, the potential difference across these components in the loop should be equal to the sum of the potential difference across these components in the loop should be equal to the EMF supplying the loop. So E should be equal to VR, so that's the potential difference across R plus VC, and that is the equation for that is the equation when you apply Kirchoff's voltage law to that loop. Okay, B says hence establish the differential equation of the circuit. Now we know that E is equal to VC plus VR, but VC is Q on C and VR is IR. Again, I is dq dt, and rearranging this equation we now get this, and this is our differential equation. Now going further, C says solve this equation then give the expression for the voltage VC. Now we just what I did was multiply by C and take this way, so we get this. So we multiply all through by C and take these two terms here to this other side of the equation, and then get this. From here we divide both sides by E C minus Q. So this goes down here and this comes down here as well, and dt goes up. So we have this here. Integrating both sides now. So initially the charge on the capacitor was 0. So initially there was no charge stored by the capacitor. So we have 0 at time 0 and at time t we have charge Q. Now whenever I integrate this, we're going to get negative ln EC minus Q, and substituting our values we now get this. So we have negative ln EC minus Q plus ln EC. So when you substitute 0 you have EC and when you substitute cure, you have this thing here. And since there is a negative, so we now have positive here and negative out here. Integrating this, we have 1 over RCT from 0 to t, which just gives 1 over RCT. Now, multiplying everything by a negative sign, we are now going to get ln AC minus cure minus ln AC, which is ln AC minus cure divided by EC, and that should be equal to negative this term here. And we can as well separate this bracket here to be EC divided by EC minus cure divided by EC, which is 1 minus cure divided by EC. So we have 1 minus cure divided by EC equals E, so the negative 1 over RCT. So we have this here. Now we are going to take cure this way and take this guy this way. So we have cure over EC equals 1 minus this thing, and because of multiplying all through by EC, we now get cure equals EC into 1 minus negative 1 over RCT. But we were not asked to calculate the expression for cure. We were asked to calculate the expression for VC. We all know that VC is equal to cure on C. Hence, if we do cure on C here, we are just going to have E times this thing here. And that is why we have this. So since VC is equal to cure on C, we now have VC as this thing here. Okay, let's look at the D part of the equation. The D part of the equation says when the switch is thrown to B, apply Kirchoff's voltage law and hence deduce its corresponding differential equation. So if this equation is thrown to C, then we have short circuited E. So we are now left with this loop, and in this loop the capacitor discharges. So if we apply Kirchoff's voltage law, this capacitor now serves like our EMF in this case. Let me put it that way. So it discharges through the resistor. Hence, the voltage drop across the capacitor should be equal to the voltage drop across the resistor. So if the switch is thrown to B, then the capacitor discharges to the resistor. Hence, applying Kirchoff's voltage law, we get VC equals VR, and VC is again cure on C equals VR is IR. So we now have cure on C equals to R d cure dt, since I is d cure dt. Hence we simplify the expression and we get this. Thank you for watching the video. Please don't forget to like, subscribe, and turn on your notification bell so you get alerted whenever we upload maybe the next exercises or the tutorials. And have a nice day.